Guys, welcome to my squaring video. That wasn't an accident, there was a purpose. No, I can't let them see the pin. Good. So, let's see what we got. So, let's see math tricks. Now, math tricks, but exponential. Squaring numbers ending in 5. How to do this? Simple. You first do x times x plus what, and then on one side, and then the next side you do 25. Like they're completely different floaties, but then later you connect them. So that's x5 squared. If you learn, let's see, the multiplication method comes behind this. If they have the same tens digit and the ones digit end up with 10, it's like the same thing. 6 times 54 is like 5 times 6, 30, and 24, which is why it works. Or am I sure? Yeah, so this is why it works now. So if you want to do 55 times 55, you do the same thing, right? 5 times 6 is 30, and then you get 25. Every method, you get 25. So, but in the other words, it doesn't add up, so that's why. Now, this is why you get this. Now, that's that, but how do you square numbers ending in 2, 5? This is going to be for 3 digits. But, like, 1, 2, 5 squared. Let's see here. Okay, I hope you can see the font clearly. So according to this method, you first do 1 plus its half is 0.5, it's 1.5. They say to multiply by 10, and then put on the other side 620 and 25. Yeah, and we got it. So 325 squared is obviously 3 plus 1.4, 5, well, it's 4.5 times 625. What? But then I notice you don't do this. You add it. And you get the half. You do get the half. But you add it by 1. You add 1. Because you add it square. So this is why this is not 15,625. Still, no. 255,625. But here it's not 45. It's 9 plus 4.5. Now it's 13.135. 625. Now we've seen this. Oh, it did 325 here. But wait, let me see. 9, 1.5. Oh, you don't add 4.5. You get 9, and then you get plus 1.5, and then you get 10.5, and then you do the method. Oh. So if you want to do 425 squared, it's first do 16, then to 18, 180, 625. Simple. Now let's do for a different difficult one. 15. I can't even understand here. So basically it's saying 1,215. It's 12 squared plus 12 and a half times 10 minus 2. Okay, yeah, this is just too complicated. And 15 is just too complicated, but let's see if there's more easier ways. Oh, so you just take, okay, now this one for 75. Now this one might be kind of complicated. This one was my old one. When after that, I broke in tears because of my dad. But, okay. So let's do 75. Let's add it on the scene. 175 squared. How do you do this? First take 1 and 5. And then you multiply it. Plus 1 times, no, then you take this 1 plus 1, 2, 30. So 30,625. Now in this case, the 200 would be 40,000. So it seems okay. Mostly. Now, let's use the other one. 375. Now this is epic. 35 times 4. You follow this method. Now it's 35. With this 4 method, we just do. So, 35, 70, 140. Now that's 140. For yeah. And take the 6 to 25 as usual. Now, this is 75, but what about 95? Oh, so take that, add 1, then multiply by 10, then subtract it by its own thing, and then put 0 to 25. Okay, so 195 is saying it should be 1 plus 1, 2. And then what do? 2 squared times 10, 40, minus 2 itself, 38. And then when you get this 38, saying 38, 6. I'm disgusted. But at least we know it. Okay. Now let's do 190. Let's do 395. Yeah. Well, 3 plus 1 is 4. And that's square. 160 minus its 4 itself, and then you get the disgusted. Well, yeah, 160,000. I can't blame you. It makes sense. This is a good thing about this trick. It makes sense. 5 plus 1 is 6, so 360 minus 6. 356, no, 354, 0, 2, 5. It's just it's pretty simple. That's the good thing about this trick. Now, guys, we can't do this. We have to do more. Let's do large numbers. Okay, 1,795 squared. I've just thought of the largest number I can think of. 18 squared. I know 18 squared by a fact. Just minus 18, which is good. At least I know 18 squared. Now 3. Thought so. 2. And then 2, 3. 3, 2, 2, 2. But that's not done. 3,222,000, then 25. See, this is why I like it. Now it's whoa, whoa, Then 196. Well, we got this 196 from 14 squared. Now we take it 10, then we take 14 out of itself. And then 1946, 0255. Okay, we've done enough 95. I think let's just see if we can actually square a normal random 2-digit number by ourselves. Well, okay. So let's use this method to use 12 squared. Now I have to do this. Then you have to do this. I have no idea what we're gonna do. Right, you do 2 squared. You do 1 squared. 1 squared. 1 times 2 times 2. No, because... And now 26 squared. This one's a little harder. And then what's 2 times 6 times 2? Now we have to do regrouping here. Well, it's 7 because of the 6. Now guys, this is how you just square a normal number. Now let's see. Now we know from 1 to 10, but what about 10 to 20 squared? Well, simple. 11 squared is 121. 144 is 12. 169 and 26 is 13 and 14. 14 has the larger. 13 has the smaller. 225 is 15. I think you know that by now. Then 256 is 16. 289 is 17. 324, you remember from 18. 361 from 19. Finally, 400 from 20. And to know more. 441, 21, 484. These are the basics. But what about 509? 529. Its odds are pretty basic. So we did it not only from this, but to this. Now we have seen squaring. Squaring was a good thing, and we can see 3-digit squaring too. Now 3-digit squaring comes with 2 digits, but it's the same thing. Now we're doing 109. Now I know this basic method. So 10,000. Well, this area is actually split. 200. It's actually going to be this. This is the answer according to my method. Let's see if this method works out too. So of course we're going to keep. Now what's 0, 1? Okay, we can't decide 1. And then what's 1 times 9 times 2? 18. And then we do 9, 81. Okay, we just got an answer. 123 squared. This one's a little harder. 1. Then 1 times 2 times 3. No. Now this one is kind of complicated. I think in this method we actually do 1 times 23 times 2. Yeah. 1 times 23 times 2. So don't get confused. 46. And we got 46. And then we get 09. Now let me go ask the calculator. Is 14609 correct? Okay, Google. What is 123 squared?
123 squared is 15,129.
Okay, trust me. I can't just inhale this person's breath. Oh my God. I can't survive with this guy. Now 1 times 23 times 2. Now what's 3? Oh! I forgot to tell you, it's not 3 this time, it's 23. This is the hard part. Now remember from our just list, 529. It's 5, 1, 5, 1 to 9. If you forward back a bit, you'll actually see that was the right answer. Oh, now that was my mistake. I'm sorry. Really sorry. Now 243 squared. This one's going to be a wild one. We'll actually have multi-steps in here because we have to do the 2-digit method too. First, 4. Then 2 times 43 times 2. Now this one's going to be 4 times 43. Now let's do like this. 86, 172, 172. Okay. What's 43 squared? Guys, what? Now let's do this. 16. Well, it goes on. 9. And what's 4 times 3 times 2? 24. Now, guys, we got it 1,849. Now, we're only allowed to have 2 numbers on the board. So it's basically saying, what's 72 plus 18? I have a feeling this is special. 90. Of course. 59049. Now let's see if this is right. Okay, Google. What is 243 squared?
243 squared.
Yes!
59,049.
Yes, I proved you. Now, this is a paradox. Which not only 3-digit workers you can work in, 4 digits can too. But enough with squaring. We've gone crazy with squaring. Okay, guys, we've been crazy with squaring. Time to do some cubing. Now, let's just solve this last question to go. Simple. There could be 3 numbers on this thing now. It's just like this. It just increases its numbers on each thing. Now, now 1 times 23 times 2. This case, 46. But since there's supposed to be 3 digits, this is where it comes. Now, this is the weird thing. And then what is 23 squared? 509. This is where the gum card comes in. No, 529. Let me take this sheet to go. Okay, Google. What is 1,023 squared?
1,023 squared.
Yes.
1,046,520.
This is just a big paradox, man. This squaring is a big paradox. Now, guys, I have to get more sheets. Okay, we've just seen, I've just got more papers, and now it's for the biggest paradox. Not cubing. Now, guys, let me experiment. Now I have to experiment. I think I should have done this at the beginning. I think you'll get a sneak peek of my title. I don't want this. Ooh, 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 ooh. The word of 2 squared, and then 1. Oh yeah, 7. And then what is this game? Okay, give me a second. So basically, let me test my method. 1. Then it should be 1 times 2 squared. I believe what you're saying. 1 squared times 2. Okay, so I got my order because let's do cubing a number ending in 1. What is 51 cubed? This might seem as a crazy question. Now let's see, 4 bars. This is gonna be starting something new. Now, first of all, we have 4 bars. We first, in this method, start backwards, because if the one digit is 1, you start backwards. We do 1 cubed, and then 5, 1, then 5 to the second, and then 5 to the third. But guys, we haven't even reviewed 1. Yeah, let's get to that. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed, what is it? 216, 343. What is it? For a second, I'm forgetting. Wait, so I forgot 8 cubed. I can't believe it. Okay, good. You can still save it. Okay, phew, we saved it. 512. How did I forget that? Okay, now let's use it here. Guys, this is like the stairs paradox. This is the stairs method. So 1. Then we get this. Then we get this. Then we get 125. It can only be 1. But now here comes the hard part. You have to double each number in the central. But you have to do this. Then you can keep these numbers to normal. But wait, 1. Then you add 5 plus 10, 15. Then you add 25 plus 50, 76. But 1, 76. And then 132. So this is our answer. Now let's do it with tens with 1s. These are gonna be pretty small then, which is good. So 12 cubed with the, I didn't do it with the tens and 1s method. I do it with all of them without the special unique thing. But in here it's unique. It's like the opposite. Usually we would actually start from the 1s. But okay, 1. Then we get 2. Oh, then we get 4, 8. Okay, good job. We have just maximized, reduced. Now 8. And then this is 12 mostly. But it's actually the same thing. When you realize it, it's actually the same thing. 68. Yeah, it's basically the same thing. So guys, let's do a mission. I know 11 to 15. Okay, so 11 cubed is 1331 for you guys. It's the most easiest. It can work with any method. I'm going to teach you soon. This is also pretty good for memorizing. I'm not sure about 15 cubed. So if I get it wrong, you can't blame me. And then 16 cubed, what is it? let's use their method. 1, 6, 36, 216. But you still have to take this 21. $2,000. Six 36 to 16. Dum da 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 dum. Oh, I forgot my doubles. Guys, do not forget your doubles. Now I have to do 108 plus 21. 129. Oh my god. And I still have 12. 18 plus 12. 18, 30, if you calculate it. 4,096. Okay guys, we went far, but there's still more to come. Numbers which are the same, just result in this. X cubed, X cubed, X cubed, X cubed. Now guys, let's try with 11. Finally. Now we do 1, 1, 1, 1. Seems simple, 2, 2. Seems simple, it is definitely simple from here. Go. See? Memorize it and do it in seconds. Plus there's 11's trick. Like, and simple. You just add, but you don't add the middle. Okay, that's what I discovered. But there's the last thing. One last thing. You made it far this video. You're a good man, Petition. It's a bit long and tiring. The actual trick begins. 27 cubed. Let me remember the order. First, you should do the lower number, the smaller number, the front number, the number in the front first. And then multiply it by its square, by the larger number square. So, 27 squared, it would be like 2 cubed, 7 cubed. You would deal out with these numbers. Let's do it. 8, then 343. But what's the middle? Oh, I realized it's 2 times 7 squared. Then it's going to be 7 times 2 squared. They're different, trust me. $98. $28. So now we have to deal out like this, like a deck of cards. This is like Delta with a deck of cards. Now this is tiring. This 27 cubed is the worst equation we can find. It's the worst. Have you ever seen more tiring stuff than this? 4 times it's 56. No, 30 plus 8. Have we gone too far? We've gone too far. Oh, I don't even think this is the right answer. I think we've gone too far. Yeah, this has gone too far. This has gone too far. Something's wrong. One thing is wrong, I assure you. What? One thing was wrong. I think the location was wrong. It can't be this big. It's impossible. Tens. But okay. Now let's see one final thing, which I might have to check with Google. Okay, Google. What's 1,001 cubed?
1001 cubed is 1,003,003,001.00000001191.
Why does it give that? So, I forgot to tell you. Okay, so first, you do this. You do 1. Then on the next bar, you do this x times 3. And then on its side, you get it. X times 3. Yep, so 1. And then it's x times 3. Yeah. But you know why this comes into effect? And then you multiply this like x times 3. Then the next one is x times 3. But then it's x again. And then it's x cubed. So if it's 2, it's 1008, 016. Why not? Wait, no. 6, 12. And then, so 03, 009, and then I got the 027, 027. That one was special. That's 2003.